A very good morning to our Honorable Lecturer, Dr. Mohammad Norihan. We are from Group Number 1 are going to present our mini project today. First of all, I would like to introduce ourselves. My name is Devraj Kalyanan and my matrix number is CD210012. Now, let's get into the presentation. First of all, what is dynamic? Dynamic is a subdivision of mechanics, deals with the movement of physical objects in relation to physical factors that influence them such as force, mass, momentum, and energy. We will see the study of kinetics of a rigid body involving the wheel of a bicycle in our slide. What is the objective of this mini project? It is to comprehend the relationship between velocity and acceleration of the particles within a rigid body and its translational and rotational motion. Secondly, is to analyze and calculate the relative velocity of the rotating wheel of the bicycle. Now, I pass it to my friend. Thank you.
Hi, good day. My name is Imichi and my matrix number is DD220070. And now I will present about the case study description for this mini group project. So in Malaysia, cycling is not a well-liked recreational activity but also a competitive sport. Cyclists frequently deal with various dynamic influences during their rides, such as hills, mountains, and flat roads with headwinds. So these dynamic factors can significantly affect the cyclist's speed and efforts. When a cyclist encounters a headwind, it will create additional resistance against their forward motion. So, the stronger the headwind, the more resistance the cyclists experience and make it more difficult to maintain their speed and momentum. Thus, it is important to understand how headwinds affect the cycling performance. So, to analyze the effect of headwinds on cyclist performance, we will explore the topic of the kinetic of rigid body. So, this branch of mechanics focuses on studying the motion and force acting on objects that maintain their shape while in motion. So by applying the principle of dynamics and studies of rigid bodies, we can know how headwind velocity on flat roads affect the cyclist's performance. So through this case study, we aim to explore the relationship between the cyclist's velocity, the velocity of the headwind, and the resulting absolute velocity of various body parts. So this is the case study question for our group project. The figure shows a cyclist is riding on a flat road with a constant velocity of 20 km per hour against a slight headwind. Calculate the speed at which the cyclist should ride out and back to achieve the maximum and minimum magnitudes of the absolute velocity of the pedal air for the round trip. So that's all for me. Thank you.
Hi, my name is Cik Muhammad Nakib bin Cik Barum. My matric number is DD200787. So now I will present methodology for our project. The research team decided to use the relative velocity idea, which is primarily a subtopic in the kinetic of rigid bodies, to analyze the maximum and lowest magnitude of the absolute velocity of the pedal to better understand how headwind will affect cycling performance in road race. The relative velocity of a body is the velocity observed when it's approached or moved away from another body, where one or both bodies are in motion. Since velocity is a vector quantity, it's considered both magnitude and direction. The sign associated with the relative velocity indicate the direction of the relative velocity in relation to a reference direction. Relative velocity involves the motion of two bodies and is not solely the difference between their velocities. The magnitude of the relative velocity of bodies moving toward each other or moving apart in opposite direction is calculated by adding the speeds of the two bodies, considering their direction. On the other hand, when two bodies are moving in the same direction, the magnitude of the relative velocity is the difference between the speed of body A and body B. If two bodies are moving in the same direction at the same speed, then the relative velocity will be zero. So next I will explain the calculation. So the question is, calculate the speed at which the cyclist should ride out and back to achieve the maximum and minimum magnitude of the absolute velocity of the pedal A for the round trip. So the cyclist should pump steadily to maintain a constant speed of 20 km per hour against a slight headwind. Okay, firstly, we must to find initial velocity. To find the initial velocity is 20 km per hour multiplied by 1 hour per 3600 seconds. So we get initial velocity equal to 5.56 meter per second. Next, we must find angular velocity. So the formula to find the angular velocity is radius A multiplied by initial velocity per r. So we get angular velocity is equal to 7.30 rad per second. So now we can calculate the maximum velocity and minimum velocity. So to calculate the maximum velocity, it is initial velocity plus velocity of A. So we get maximum velocity is equal to 6.66 meter per second. Finally, we must to find the minimum velocity. The formula is same as to find the maximum velocity, but we must to change plus to minus. So initial velocity minus velocity of A, so we get 4.47 meter per second.
Assalamualaikum, my name is Afiq Naufal bin Mat Rashid. So I will present about the discussion. In discussion, in this project, we decide to do a case study on the kinetic of a rigid body involving a bicycle wheel. We choose the bicycle wheel since it is widely seen, ready, available and familiar, making them accessible for experimentation and discussion. We had used the case study to determine the relative velocity of the bicycle wheel. Aside from that, by carrying out this case study, we also accomplish our objective of comprehend the relationship between the velocity and acceleration of the particle within a rigid body and its translation and rotational motion. The design of the wheel makes calculating the translational and rotational velocity of the bicycle wheel simple. The other objective that we achieve is to analyze and calculate the relative velocity of the rotating wheel of a bicycle. By calculating it, we can understanding motion, analyzing bicycle dynamics, researching wheel ground contact, evaluating design element, and ensuring safety and efficiency that are all important. It reveals how various points on the wheel move in respect to one another and the ground, influencing stability, maneuverability and performance. The relative velocity assists in optimizing design choice, determining contact point characteristic and identifying potential vibration of or stress issue. We can improve overall bicycle performance, handling and safety by calculating relative velocity. We obtain information for case study from a variety of sources like book, journal and internet. We needed to discover an answer to a topic that involved multiple conditions such as headwind and so on. The wind blowing in the opposite direction of the cyclist, creating resistance and drag. In this case study, we use right body kinetic to solve and analyze the headwind velocity and how it will affect the cyclist. The condition in this case study were as follows. A cyclist pumps steadily to maintain a constant speed of 20 km per hour against a headwind, and the question asked for the greatest and minimum magnitude of the absolute velocity. The velocity was calculated using a variety of formulas. This is discussed completely in the preceding phase through the intensive step of calculation. The calculation yields a maximum velocity of 6.66 meter per second and a minimum velocity of 4.47 meter per second. The distance for OA is 50 cm and its radius is 0.3 meter. From this case study, we learn more about the kinetic of rigid body and its effect on the bicycle wheel from this case study. It improves comprehension of motion mechanics by providing insight into the wheel stability and maneuverability. This knowledge can be used to optimize wheel design, increase performance and solve rotational motion difficulties. Understanding the dynamic of a rigid bodies provide individual with problem-solving ability as well as a foundation in mechanics which can be useful in a variety of disciplines. Aside from that, it taught us about headwind and their effect on the cyclist. The recommendation for this case study makes use of a correct bicycle system that works flawlessly to reduce friction caused by the internal mechanics of the wheels. That's all from me.
Assalamualaikum, my name is Ella Fatia binti Rasli and I'm entered STD 220059. So I'm going to explain about the conclusion for this project. So in the conclusion, this project focus on the study of dynamic and specifically on the kinetic of the rigid body using an example cyclist riding against headwind. The objective was to comprehend the relationship between the velocity and the acceleration of particles within a rigid body and its translational and rotational motion, and to analyze the relative velocity of rotating wheel of a bicycle. Through this case study, we explore how headwind velocities on flat roads impact a cyclist's performance. It was observed that headwinds create additional resistance against the cyclist's forward motion. Similar to riding uphill, require a cyclist to exert more force and energy to overcome it. The stronger the headwind, the more challenging it becomes to maintain the speed and momentum. Last but not least, this case study of kinetic of rigid body provided insight into the dynamic of cycling and how headwind velocities affect a cyclist's performance. By understanding this principle, cyclists can better adapt to various dynamic influences and optimize their speed and effort while riding. The study of dynamics and the analysis of rigid body kinetics have practical applications in these fields such as sport, science, engineering and transportation, contributing to advancement in performance and efficiency.